Meet the toy that seems to break every rule of physics. It's not magic, and no, there aren't hidden magnets. This is a gyroscope, and today, we're going to find out why gravity seems to lose its power whenever this little will start spinning. When it's still, gravity wins. It pulls the center of mass down, and clunk, it falls. Gravity is relentless like that. But once it's spinning, we introduce a superstar of physics, angular momentum. Think of it like the gyroscope's stubbornness.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
Find this using the right-hand rule. If you curl the fingers of your right hand in the direction of the spin, your thumb points to the angular momentum vector. This vector wants to stay fixed in space. The faster the spin and the heavier the wheel, the stronger this vector becomes. You've seen this in the Olympics. When an ice skater pulls their arms in, they spin faster. That is conservation of angular momentum in action. Or try holding a spinning bicycle wheel. If you try to tilt it, it fights back. It feels alive, pushing against your hands with a surprising force. The gyroscope does the same thing. It wants to keep its axis pointing exactly where it started, and it's willing to fight gravity to do it. Here's the plot twist. When gravity pulls down on a spinning gyroscope, it creates torque. But because the wheel is already moving fast, that force doesn't make it tip over. Instead, the force gets redirected 90 degrees. This sideways dance is called precession. According to the Feynman lectures, it's all about the change in the angular momentum vector. The slower the spin, the faster the precession. It's a delicate balance between the spin of the wheel and the pull of the Earth. This isn't just a desk toy. Your smartphone uses tiny MEMS gyroscopes to know when you're playing a racing game. It tracks every tilt and turn. Before GPS, pilots relied on gyroscopic compasses or artificial horizons to know which way was up when flying inside thick clouds. Massive ships use giant gyroscopes deep in their hulls to keep from rocking passengers into seasickness during storms. Even the Hubble Space Telescope uses them to stay perfectly still while snapping photos of galaxies billions of light years away. No friction, no gravity, just pure physics. But even the best dancers get tired. As friction slows the spin, the angular momentum weakens. The torque from gravity finally wins, and the smooth precession turns into a wobbly struggle called nutation before the inevitable crash. Gravity always gets its way in the end. The gyroscope is a reminder that the universe doesn't always behave the way our intuition expects. Stay curious and keep spinning.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.